Okay, looking at number 25, it's a graph, and you could think of this as y is less than or equal to x squared minus x minus 1. You should realize that it's a happy face parabola. It'll be a solid line because that line underneath there. So since it's a parabola, you want to find the axis of symmetry. So x equals the negation of b over 2a. And in this case, x equals negative the b value. There's a negative in front of x. That's really negative 1. And the a has a 1. There's nothing in front of the x squared, so that's a 1. So what this comes out to be is x equals negative and negative is a positive 1/2. So that's going to tell you where to start your chart. So you need to do a chart for this. So on your paper you should have a chart, and you're going to, the center of your chart is going to be at 0.5, which is, or 1/2 or 0.5, whichever one you want to use, which is not a nice number, but you can go up and down from there. So we can go up to 1, 2, and 3 here, and we can go down to 0, -1, and -2 here. So as we learned this in class, I said to square everything first. So we're just going to square column 1. So 3 squared is 9, 2 squared is 4, 1 squared is 1, 0.5 squared is 0.25. You can use your calculator if you have to. 0 squared is 0, -1 squared is 1, and -2 squared is 4. All right, so we have our first two columns made. The next column is going to be for the negative x. So we're going to take whatever x is and negate it. So that would be -3, -2, -1, -0.5, -0 is 0, negative a -1 is 1, and negative a -2 is 2. Basically take the opposite of x. The last column is for the -1, and we're just going to put the -1 in each one of these. Now, since we have a trinomial, a quadratic trinomial, we have 3 things to add up, and we have our 3 things to add up here. Okay, so once you have your 3 values, your x squared, your -x, and your -1, you're going to combine these 3 together to get your y value to graph. So if I combine these, I get 9 minus 3, or well, 9 minus 4, which is 5. So if I combine these 3 here, I'm going to get 1, looks like. This one's going to be -1. This one here is going to be, -1.25. This one here is going to be -1. And notice now they're starting to repeat. This here is going to be 1. And this is going to be 5. So as you see, and this is a good clue that you did it right, is they're symmetrical around the axis of symmetry. Okay, so you're going to graph the x and the y column. So 3, 5 is what you're going to graph. 2, 1, 1, -1, 0.5, and -1.25, which we'll show you how to do that in a second. 0 and -1, -1 and 1, and -2 and 5. We're going to graph all these points on your graph paper. So I'm going to do it on here. So 3, 5. 3, 5. 2, 1. 1, -1. It's a little tricky here. 0.5, 1.25 is like in here somewhere. 0, 1, or 0, -1, sorry. -1, 1. We're coming up the other side, and -2, 5. So as you see here, your graph is symmetrical around 0.5, and it's hard to graph 0.5, but you can get an idea here. Most likely the graph on the exam will be a little bit more reasonable than this. Okay, then try to connect the dots as best you can. I'm using software here, so connect the dots as best you can, and it's going to be a solid line because of the equal to sign up here. Okay, now that I have my graph, I need to shade for this question because it is a less than or equal to situation. And most likely it's below the parabola. But let's test the value. Let's put 0, 0 in there. So if we test our value, we just do a little test up here. Is 0 less than or equal to 0 minus 0 minus 1? Is 0 less than or equal to -1? And the answer is no. So we're going to shade below the parabola. So this is a shading question. And all below and outside the parabola would be shaded. And your solution would be out here. Now, if the sign said greater than, it would be inside. So greater than or equal to is inside the parabola if it was greater than. Okay, but it doesn't say that, so we just have our solution on the outside. Okay, so that's that question there. That's the type of work you need to be able to show on the final exam. Now we're on to 26, which is a very quick question. We've seen this one several times. We have a triple on top and a triple on the bottom, so it's going to break up into two sets of parentheses. So triple starts with 3, 2 parentheses. We're going to look at the -24 to add up to -2. And I think it's 6 and 4, and it looks like the 6 is negative. So I got x minus 6, x plus 4 at the top. And then the bottom, I have a -36 to add up to -5. So -36 add up to -5. And I'm thinking 9 and 4. It looks like the 9 is negative. Okay, and then this cancels nicely, and your final answer is x minus 6, x minus 9. Okay, moving on to number 27. Okay, you're given a rectangle with an area, and you're given the width, and we need to find the length. And to do that, we divide the width into the area. Okay, so you need to show that you can do polynomial division. And again, to do this, we look at the first value of each line. And we say what times that first value equals the second value. So I'm going to x squared times x is x cubed. Now don't forget to multiply both items with it. Okay, so again, don't forget to multiply both items here. So I did one. Now the other one's going to be -2x squared. -2x squared. So now this is where you got to be careful. Got to subtract. When I subtract, I make this a minus and this becomes a plus, and I combine these two. This becomes 0. This becomes 3x squared. Beware of that. The next term, okay, and I'm sorry, we can bring the rest of our terms down. Okay, the next step is doing the next step is to look at again at the first term here and the first term here, and how do I make the x up here look like a 3x squared? And you're going to multiply it by positive 3x. Again, don't forget to multiply both things by positive 3x. and you're going to produce a 3x squared here, and then 3x times negative 2 is negative 6x. And you're going to subtract again. So don't forget to change the sign here and make this a plus 6x. When you combine these two here together, you get negative 2x plus 2. And of course, there's a 0 here, which we don't show. Now our next step is the same as the previous two. Look at the first term here and the x here, and how do I make this x turn into negative 2x, and I would multiply by negative 2. When I multiply both terms by that, I get negative 2x plus 2, because a negative times a negative is a positive. When I subtract, I get a remainder of 0. Now you have to answer the question. Find the length of this. The length, oops, I spelled that. Length, no, I didn't spell it. The length is x squared plus 3x minus 2, and don't forget to label it meters. Mistake in there. Okay, seems to be that we made a mistake, or I made a mistake here. So negative 7 subtracted from 6, or minus 6, is a plus here, but I combine these, it's negative x plus 2. So this 2 up here is incorrect. Another good reason to use pencil. This answer is incorrect. And I really need to multiply this by negative 1. So I'm going to get negative x plus 2, which gives me a remainder. It does give me a remainder of 0. Yes. Sorry about that. So negative 1 times that and negative 1 times that gives me negative x plus 2, which is a remainder of 0. So my final answer, still written, the length is x squared plus 3x minus 1 meters. So I apologize for that. Let's just zoom this out. Hopefully you didn't stop the video after I got that answer. So again, my mistake here was I subtracted wrong, and then I multiplied wrong after that, so sorry about that. Okay, looking at number 28, a word problem, and let's read it. The sum of two numbers is 82. Okay, the sum of two numbers is 82. Their difference is 24. Write a system of equations that describes the solution solved by elimination and find the two numbers. Okay, the sum of two numbers, so we need two numbers. X could be the first number, and Y could be the second number. And you need to, we could finify this. We're going to finify it. So the first, it's asked for a system of equation, which means two equations, two unknowns in this case. So the sum, which is x plus y, is 82. And the difference, which would be x minus y, is going to be 24. And we need to solve this system of equations. And it tells you by elimination, which is very nice of them to do. So we could just go ahead and just add these two lines together. And what will happen is you'll get x plus x. And remember, there's a 1 here and a 1 here. That's 2x. And 1y minus 1y is 0 equals 106. Okay, and then just to get our answer, we can just divide by 2 when we get x equals 53. Now, you're not done yet. You still need to find out what y is. Well, we can do that and do the check at the same time. So if we get y for both equations to be the same, we've checked our work. So we can take 53 plus y equals 82 for the one equation, and we can do 53 minus y equals 24 for the other equation. And if we solve these and y equals the same thing, we've done a check. Okay, let me just go back real quick. I got the 106 by adding these two together, and then I divide by 2 to get x equals 53. So we still have to do the check here and see what y is. So I'm going to minus 53 from both sides. Okay, and I get y equals, if I do the subtraction here, I believe it's, no, it's not 21. 29, sorry. Okay, now I can solve this one for y over here, or I can just plug in 29 and see if that equals 24. And it does. So what I've done here is I've checked my equation, or I used one equation to get y equals 29, and then I checked it with the other one to get a check. So my answer is 53 and 29, but I have to present that. I have to answer the question. The question says, what are the numbers? The two numbers are, so again, to finish off the problem using Infinity 5, the two numbers are 53 and 29. Okay, looking at 29, write and simplify a rational expression, meaning a fraction, that represents the probability, it's another fraction, or it's still the same fraction, of randomly hitting the unshaded region of the rectangle. Show all of your work. Okay, we need to find the area of the larger region, which is the outer region, minus the area of the shaded region, which is the smaller inner region, and that will equal the area of the cutout region. But since it's a probability, we're going to divide that by the area of the larger region, which is just the white box by itself without the cutout. Okay, well, what does that mean in mathematical terms? Whoops. That means we need to make up a rational expression here. Well, the area of the larger box, the area of a box is base times height, or a rectangle base times height. So I'm going to just take 2x plus 5 and multiply it by its height, or its width, whatever you want to call it, x plus 5. And I'm just following along here. So that's the first set of parentheses. Minus the second set of parentheses is going to be these two multiplied together, which is x plus 5 times x plus 3, all over the area of the white box, which these two are the same, so I'm just going to repeat this. 2x plus 5, x plus 5. Now the trick to these problems is to cancel before you multiply and subtract and do the math here. Since x plus 5 is in both of these, I can factor them out and cancel them with the bottom. Okay? What that leaves behind is 2x plus 5 minus x plus 3. Now I got rid of the parentheses on the 2x plus 5 because I don't need them, and I want to make sure you distribute this negative sign to both of these terms here. That's going to give us a new top here, 2x plus 5 minus x minus 3, and it's still all over 2x plus 5. And you can't cancel the 2x plus 5 because it's not under the operational multiplication. At this point, it's just combining like terms. The 2x and the negative x make an x, and the 5 and the negative 3 make a positive 2, and that's still all over 2x plus 5. So this would be the probability of hitting the region asked for, the non-shaded region it asked for. So let me zoom that out so you can see the whole picture here. And we've seen this question before. So you set it up, you cancel, make your life easier, distribute, subtract, or combine like terms, and then you have a probability at the end. Okay, that takes us to number 30, which is a very difficult question if you don't take it piece by piece. Okay, so we have something we're adding and then dividing by a fraction. So this here is going to be multiplied and flipped eventually. You have to notice a few things about this question. Well, let's deal with the first parentheses here. If we're going to combine these two, usually in math, if it's apart, put it back together. So we need a common denominator here. Hopefully you see the common denominator is x plus 4, x minus 4, meaning that this one on the right needs an x plus 4, that says x plus 4, and the one on the left needs an x minus 4. Well, when you do that, you create this expression. Okay, and that's all going to be over x plus 4, x minus 4, which really is, so watch this, x plus 4 times x minus 4 is really x squared minus 16, if you were to multiply it out. Okay, so that was a little bit to digest. We've still got a lot of work to do here. Now we're going to multiply and flip. What you're going to hopefully see that 2 goes into both of these numbers. So when we bring it up top, let's take a 2 out. Then you're going to get x squared minus 16. And that's one of the tricks to this, because we have a cancellation eventually here. Okay, well, actually, we can cancel right now. We can get rid of this right away. We still have to deal with the top, which is a bit of a mess. So the way you deal with the top is distribute this x, distribute the 6, and then we're going to combine them, kind of like the last question. So when we distribute x times x is x squared, plus 4 times x is 4x, plus 6 times x is 6x, and 6 times negative 4 is negative 24. Okay, that's still the top over here. Now it's over 1 because we canceled. We still have to multiply by 2 over 3 because we canceled over here. Okay, so we're going to just clean this up a little bit. We're going to combine like terms, and the only like terms are in the middle here. So this is x squared plus 10x minus 24. And then we need to multiply that whole thing by 2/3. So we can just put a 2/3 out front like this. I don't know if I showed you the answer key, but if I did, I think they might have distributed the 2 to each one and gone 2x squared plus 20x minus 48. Oops, sorry, 48 over 3 would be a reasonable answer for this question. Minus 48 over 3. Okay, so if we look back at this one, again, this is the amount of work you'd have to do for this type of question. It'll take a second to do it. You should be able to mirror this question on your own. Try it without looking. And if you have to watch the video partially through, do that until you're successful doing this on your own. Okay, we're going to do the last one, number 31. This is a lot like the previous question, except it's not a probability. It just wants you to find the area of the shaded region, which, again, is the area of the larger region. And I'll write it a little different, minus the area of the smaller region, not shaded. Okay? So the area of the larger region would just be this times this, 2x plus 2 times 3x minus 4. And then we're going to subtract the area of the smaller region, which is x minus 3 times x minus 6. Now, to do this question, you could use FOIL or the box method. I'll do box method on one and FOIL on the other. But I got to remember to subtract the two answers. So if I do box method on this one, 2x plus 2 times 3x minus 4, I'm going to get 6x squared, 6x, negative 8x, and negative 8. Okay, so as usual with the box method, usually combine the diagonals. This is going to combine to a negative 2x. Okay, so this answer here is 6x squared minus 2x minus 8. We're going to subtract that from the, we'll FOIL this one, so I'm going to go x squared. I'm going to add these two together, which is negative 9x, and multiply these two together, which is positive 18. I believe I did that right. I kind of did it quick.
Good, yeah.
Okay, how did I do that? I did first, outer, inner, and then last, the FOIL. Or you could just use the box method. You're going to get the same answer. I suggest the box method if you're not confident in using FOIL. Okay, we still need to subtract here. Let me get rid of this. We still need to subtract. So subtraction, you got to remember, it means subtract everything. So, and I could write it this way, 6x squared minus x squared. And then let's go with the negative 2x minus the minus 9x. And then do the negative 8 minus the 18. Okay, and if you're bad with negative numbers, use your calculator. This should be, 5x squared. Add the opposite here is going to be 7x. And again, add the opposite here, and you got negative 26. So this would be the final answer, which is the area of the shaded region, which is the outer region here, the area of the shaded region.